Imagine this. You're in a crowd, the energy is electric, maybe it's a concert, maybe a festival, but then the pressure starts building, the air gets thin, and suddenly that joyous atmosphere turns. Well, terrifying.
Yeah.
Crowd accidents, from the tragedy at 801, the Love Parade disaster, or incidents during the Hajj pilgrimage, they're sadly recurring events.
Mm-hmm. And they're not just random, are they? They're really complex.
Exactly. Complex phenomena influenced by, well, everything from the words we use to describe them to the hidden physics of how crowds move, and even the psychological aftermath, which can be profound.
Absolutely.
So today we're taking a deep dive into a fascinating stack of research that peels back the layers on crowd accidents.
Our mission really is to extract the most important insights, give you a shortcut to being genuinely well-informed about this critical topic.
Right. We'll explore how the media shapes our understanding, the surprising science behind crowd movement, which is pretty wild, and what it truly takes to, prevent and recover from these devastating events. Okay, let's unpack this.
Let's do it.
So we'll start by looking at how the media portrays these accidents, how it influences public understanding, emotional response, that sort of thing. This comes from a big analysis, 372 media reports covering over a century, 1900 to 2019, plus Wikipedia narratives. So what did this linguistic deep dive turn up?
Well, one really striking finding is the strong prevalence of the term stampede in media descriptions.
Oh, stampede. Yeah, you hear that one a lot.
You do, but it's often used incorrectly.
Yeah.
While panic also shows up, the research really highlights that in many situations, crush will be a much more accurate description of what's actually going on.
A crush.
And interestingly, we've seen a gradual shift very recently, maybe in the last few years. Terms like crowd crush are becoming more common, both in media and Wikipedia. It signals a kind of evolution in how we're labeling these things.
It's fascinating how our common language can be so different from, the scientific reality. So if stampede often implies the sudden rush, people fleeing,
Right.
what's actually happening in these crush events, why is it different?
Exactly. If you look at the dictionary, stampede suggests running, fleeing, a chaotic rush. But a key finding here is that actual panic behavior, it's reportedly quite rare in fatal crowd accidents.
Really? That's surprising.
It is. So using stampede for accidents in these really dense crowds where there isn't that kind of flight behavior, it's problematic. It gives the wrong picture. And even in science, the definition of panic can vary quite a bit depending on the field, which adds another layer of confusion.
And the way the media uses these terms, it's not just about accuracy, is it? It's about the emotional hit.
Definitely.
And it gets even more dramatic, apparently. The sentiment analysis showed a consistent link with, fear-related language.
That's right. This fear-infused narrative has actually gotten stronger over time, especially in headlines. You see it trying to grab attention.
Sensationalism, perhaps.
It seems likely. An attempt to attract readers, but it definitely shapes how people perceive the event and maybe even the victims.
So how do these descriptions vary around the world? Is it the same everywhere?
Not quite. There are some interesting differences. We see divergent patterns, for example, between Western media and South Asian media, specifically India and Pakistan.
Okay.
So stampede is a bit less common in Europe and the U.S., though still very prevalent. But in Indian and Pakistani media, you see the term incident appearing more often.
Incident? That sounds more neutral.
It does. It hints at maybe a cross-cultural dimension in how these events are framed and talked about.
And maybe the most surprising thing, you mentioned Wikipedia earlier, how major disasters can actually change the language we use.
Yes, exactly. Take the 801 tragedy in October 2022. Researchers compared Wikipedia pages scraped before and after that event. And they found specific instances where the word stampede or stampedes had been explicitly changed to crush or crushes or even surge.
Wow. So a direct link between a major event, expert input maybe filtering through, and the language evolving.
Precisely. It shows how these high-profile events can really force a reckoning with the terminology.
Okay, so if our words can sometimes mislead us, what about the invisible forces, the actual physics?
Now we get into some really eye-opening stuff.
Yeah, this is the part I find fascinating. The physics of how crowds move. It's crucial for understanding why accidents happen, right? You'd think it's just random people bumping around, but science says no?
Not at all. It's wild to think that even subtle things like people having preferences for certain spots, researchers call this vexation, or how they interact, the energy between them, called frustration. These can actually be used to predict how a whole crowd will behave.
Vexation and frustration, in physics terms.
Exactly. It's built into something called density functional fluctuation theory, or DFFT. It essentially lets scientists forecast crowd behavior based on these sort of hidden human forces.
Huh. And how do they test that?
Well, they've even tested it with model crowds of fruit flies.
Fruit flies? Seriously?
Seriously.
Mm-hmm.
To show how these concepts can be pulled out of density patterns and predict how the flies will act in different environments, like with heat gradients or different shaped containers.
Okay, that's pretty cool. But what about human crowds? I heard about this idea of crowd material.
Yes, that's where it gets really cutting edge, I think. New research is modeling extremely dense crowds as active matter.
Active matter, like a fluid.
Sort of, yeah. Think of it like a fluid where each person generates its own energy and motion. They're actually calling it crowd material.
Okay.
Because it behaves with predictable, almost material-like properties under pressure.
Okay.
And they're using this advanced AI system, combining physics models with neural networks. It lets them essentially read complex crowd dynamics directly from video footage, even low-quality, shaky, real-world clips.
So it's not just a black box AI. You can understand why it predicts something.
Exactly. It's a continuous time physics model, so it offers much stronger interpretability. It's like having a digital twin of the crowd showing you the forces and flows.
And that has real-world uses for safety, right?
Absolutely. Practical applications for public safety design. You can run simulations, see how behaviors learned in one setup might apply to another.
Like what?
Well, for example, simulations show a wider exit obviously reduces stress. But counterintuitively, sometimes putting a well-placed obstacle in front of an exit can actually reduce stress too by regulating the flow.
Huh. An obstacle helping, that's weird.
It is, but it's about preventing clogging right at the exit point, optimizing flow.
Okay. And then there's this other phenomenon, collective oscillations.
Ah, yes, this is fascinating. Imagine hundreds of people in a super dense crowd, maybe 4 people per square meter, really packed in.
Yeah.
Suddenly, without any external signal, they might start moving together in this giant, coordinated circle, like a massive swirling eddy in a river.
Whoa, just spontaneously.
Spontaneously. Scientists call them macroscopic chiral oscillators. They think it's driven by subtle, almost invisible odd frictional forces between people's bodies as they try to move.
And this has actually been seen.
Oh, yes. It was observed at the San Fermin Festival, the Running of the Bulls. And, chillingly, this kind of oscillation was present right at the onset of the 2010 Love Parade disaster.
Oh, wow. So knowing about this could be like an early warning sign.
That's the hope. It offers a potential protocol to anticipate these dynamics that seemed unpredictable before.
It's incredible. Crowds acting like fluids with currents. So what about evacuations? When people are actively trying to get out, pushing.
Right, then density alone isn't the full story. This idea of kinetic stress, basically, pedestrian pressure, becomes really crucial.
Kinetic stress. Okay.
Studies on room evacuations show this really counterintuitive, faster is slower effect.
Faster is slower. How does that work?
When people become more competitive, pushing harder and faster to get out, the increased friction and jamming actually slows down the overall evacuation rate.
So trying harder makes it worse for everyone.
Pretty much. In those competitive scenarios, you could even see 2 high-pressure zones, like lobes, developing at the sides of an exit where people are getting jammed. And what's more, sudden collective movements, like a surge, can happen just because of increased kinetic stress, even if the overall density hasn't changed much. It highlights these really complex, nonlinear dynamics.
And what about just static crowds, people packed in, not necessarily trying to flee?
That's dangerous too. Physics simulations of static crowds show that human injury can start with as little as a 20% reduction in the area people are occupying.
Only 20%. That's not much space lost.
No. And densities get incredibly high, over 10 people per square meter, which is considered critical for crowds of just 200 to 400 people if their space shrinks by only 25%.
Wow. That really underscores how critical just a little bit of compression can be.
Absolutely. Local density is key.
Okay, so we've got the language, the physics. What does all this complex research mean for, for you listening and for public safety in general? We can learn so much from tragedies like the Itaewon Halloween crowd crush in 2022. 159 lives lost. It really highlighted critical gaps in emergency planning, didn't it?
It really did. And a core issue often comes down to distinguishing between what authorities see as ordinary events, routine, organized things, and special events.
Special events being what, like spontaneous gatherings?
Exactly. Non-routine, high-strain gatherings, often without official organizers, like that Halloween night in Itaewon. South Korea, for instance, had strict protocols for official, planned events, but they lacked clear plans for these informal public gatherings.
So it fell into a gap. No one was responsible.
It created a dangerous void where no single public agency really took charge. And compounding that, things like illegal construction by local businesses had actually narrowed escape routes, creating bottlenecks.
So connecting this back, what do the experts recommend? How do we bridge that gap?
Well, the consensus is that standard emergency planning for ordinary events isn't enough. It must be supplemented by robust contingency planning specifically for these special, often spontaneous events.
And that involves everyone.
Yes, all stakeholders. Governments, local businesses, voluntary organizations, they all need to work together. Practical steps include things like ensuring structural safety beforehand, maybe expanding volunteer activities like having people monitor crowds and issue warnings.
Using technology too, I guess.
Definitely. Leveraging tech like drones and CCTV for real-time crowd management. And crucially, regularly testing and updating these plans, keeping them simple and realistic, not just documents on a shelf.
Makes sense. But the impact, it's not just about prevention or physical injury, is it? There's a huge psychological toll.
Huge, and often hidden. A recent study focusing on the Seoul Halloween crush revealed a really significant and lasting psychological impact.
On who? Just the people directly involved.
Not just them, obviously direct victims and witnesses, but also citizens who were only indirectly exposed, maybe just through media coverage. All these groups showed lower well-being and a high risk for PTSD, post-traumatic stress disorder.
Even if other mental health signs seemed okay.
Even then, it's a specific kind of trauma that can linger.
And what made the trauma perhaps worse in that specific case?
Well, one critical factor was the uncensored live streaming of the scene on personal social media. People were watching horrific events unfold in real time.
Ah, yeah. No filter, no gatekeeper.
Exactly. It removed any buffer that might normally protect viewers from witnessing intense pain and death directly. And then, compounding this, was how some parts of the public reacted.
How so?
There was a segment that blamed individuals, the party-goers themselves, or blamed a general lack of order rather than systemic failures. This led to intense feelings of guilt and remorse among victims and witnesses.
So they felt blamed for just being there.
Yes. And this narrative, this personal responsibility angle, significantly impacted their well-being, their social well-being too. There's a clear link highlighted between that trauma-related guilt and PTSD symptoms sticking around longer.
That's incredibly sad. And it points to the importance of reliable information, doesn't it? How we understand these events matters.
Absolutely. And on that note, other research shows something interesting about reliability. News items about crowd accidents. They're often most reliable about 2 years after the event happens.
2 years? Why so long?
Because later reports, things like official forensic investigations or final medical reports, can capture deaths that might occur months after the initial incident due to injuries. They also fill in missing data points.
So the initial reports might not have the full picture.
Often they don't. It really speaks to the need for a rigorous approach to data collection and analysis, and being aware of the credibility of different sources. Scientific publications tend to be more reliable in the long run than initial press reports, for example.
Got it. And what does that meticulous data analysis tell us about fatalities? Are there patterns?
There are. The death rate is significantly higher for accidents caused solely by crowd motion, things like crushing, pushing, stampeding, compared to accidents where external factors like a fire or collapse were also involved.
Okay, that makes sense.
And importantly, incidents attributed mainly to increased crowd density. Those quasi-static crowd crush events we talked about, they actually claimed twice as many fatalities as incidents involving dynamic crowd movements, like a true stampede.
Wow, twice as many, even though the dynamic ones happen more often overall.
Correct. Even though dynamic movement accidents account for a larger percentage of total incidents, this sheer pressure in dense, static, or slow-moving crushes is deadlier.
And where did these tend to happen?
High-risk areas are often predictable: doors, gates, narrow passages. And a key factor is often the inward movement of a highly motivated crowd, people really wanting to get somewhere specific. That focused push is a major factor in how these accidents develop.
Right. Okay, so we've covered a lot of ground here. We've navigated this really complex landscape of crowd accidents, from the subtle ways language shapes how we even perceive them.
The power of words like stampede versus crush.
To the intricate, sometimes counterintuitive physics that explains collective movement and pressure.
Yeah, the crowd material and those strange oscillations.
then the critical need for better, more proactive planning, especially for spontaneous events.
Moving beyond just planning for the plant.
And finally, the profound and lasting psychological impact, not just on victims, but on society.
Yeah. This deep dive, it really reveals that understanding these events isn't just about the surface chaos we might see. It's about these invisible forces, the evolving language we use, and the deep human element, both physical and psychological. It's all interconnected.
So here's a final thought to leave you with. As our cities get denser and spontaneous public gatherings become, well, more common, what does it really mean for us as individuals to be truly well-informed about the dynamics of crowds? And maybe more importantly, how might this deeper scientific understanding empower us all to foster safer environments and maybe more resilient communities, even when there isn't an official plan in place?